CAD Partner presents to you the Smap3D solution for 3D plant design. Fulfill the typical 3D plant design process chain with solid edge and Smap3D P&ID, Smap3D piping, and Smap3D isometric. The direct connection between these modules allows for the automatic usage of existing attributes. In the following, we will show you the benefits from each of our applications. The Smap3D P&ID is an intelligent and powerful standalone application for process engineer. An intelligent database and a large standard library are included. Intelligent design and plausibility checks, as well as a report generator, are also included as base functionality of the Smap3D P&ID software. Smap3D piping provides you with direct usage of P&ID definitions with connected to-do list functions. You can reach the highest automation for pipeline generation when working with pipe specs and Smap3D quick place technology. With the included Smap3D piping library, you are ready to start. Additional advanced functions are also included. Smap3D piping also supports the usage of non-round profiles to generate pipelines for air ducts or cable trays. With native solid edge functions, you can automatically generate 2D drawings with bills of materials in the correct length of the pipes. The isometric application provides you the automatic creation of single-line isometric drawings leveraging all of the available attributes from the 3D pipeline. The Isogen kernel uses all of this information to generate these drawings. With predefined styles, you can customize and control the display and the content of the drawings. You can choose the output format as Solid Edge DFT, PCF, IDF, or DXF. Having the 3D assembly and the appending P&ID drawing open, you see the connection firsthand. Select any component in the to-do list. It will be highlighted in 3D as well as in the P&ID diagram simultaneously in real time. Now we are going to add additional components and pipelines to the P&ID. We need a pump, which we are going to find in the component database by querying for it and placing it in the desired position. An automatic inquiry pops up and needs a unique tag number to fully define the component in the diagram. All other arrays get automatically assigned with the information and properties from the database. Symbols are getting connected with a line. First, the pipeline gets a unique number, and afterwards we assign a pipe spec and an appending pipe size. Pipelines and connected components which have a flow direction can be turned around by one simple mouse click. We are going to place a stop valve at the heat exchanger. Here, we also used a connection between the 3D pipe spec and the P&ID component database. The assigned pipe spec filters out only the admissible components from the database. In this example, the unique tag number gets created by a function which is automatically generating names. Placing the symbol, it rotates automatically to the line direction. The size of the connected pipes gets automatically written to the symbol. With an additional pipeline, we connect the pump with the tank. The procedure is the same as with the first pipeline. The intelligent design checks can be performed on the finished diagrams and only on specific parameters. Warnings and errors are going to be shown in a separate window and can be easily resolved from there. In this example, the size of the nozzle doesn't fit to the pipe size. The solution in this case is to change the pipe size. The new value is going to be displayed at the tank nozzle, which doesn't cause an error message anymore. With the Object Lister tool, it is possible to list the whole content of a diagram or a partially selected area and display it in a table, which can be edited. You can generate different lists and reports, like BOMs and parts lists from the drawing. A bill of materials, or a BOM, sums up all identical components by its article number. A component list analyzes components by its tag numbers. Apart from the usual export options, we also have an intelligent PDF export. Along with the visible geometry, you can also see the component properties in the PDF. Once the work in the P&ID is finished, you switch back to your 3D environment. After refreshing the to-do list, the changes from the diagram will be shown. The to-do list is helping the user implement changes according to the P&ID diagram. In this case, the pump gets placed first from the 3D library. And then we assign the component properties of P&ID to the 3D model. With the information from the P&ID, the 3D pipes are ready to be created. The function FromToPoints helps the user find the correct connection points. After a subassembly is automatically created, we draw a 3D pipeline path with the Solid Edge Express Route function, Path Express. To draw customized lines, just choose the Line Segment function. From the to-do list, assign all relevant information from the P&ID to your 3D pipeline sketch. With a single click, the pipeline gets generated. In doing so, piping uses knowledge from the assigned pipe spec and takes only admissible fittings from the 3D library and places them on the path. The necessary valve is interactively placed via the to-do list. For placing the valve to the pipe, the native Solid Edge and Mate functions are used. Hereinafter, recalculating the pipeline causes an automatic placement of flanges and gaskets at the valve. The last open task is to add a reducer to the pipeline. The required split point is being defined in the Express Route function. All following steps are queried and automatically processed by the software. After finishing this operation, all symbols appear green in the to-do list. For the user, this means that all information from P&ID is now implemented in 3D. If required, the pipeline can be extended with pure 3D piping functions. In this example, pipe supports are needed along the pipeline. The dedicated function gives you the desired result fast and easy. With native solid edge functions, you can make precise adjustments to the positions of all supports correctly. Through standard CAD functions, all relevant pipeline parts get displayed. It is needed to create some isometric drawings of the 3D pipelines. During the generation of isometric drawings, all available information is taken out of the 3D pipelines and is used for generating the drawings. The final result, in this case a DXF file, can be viewed or edited in a proper application. Each isometric drawing contains information which is relevant for manufacturing this pipe according to the used template. With functions already shown, Smap3D Piping can generate so-called non-round profiles like air ducts. The only difference is that piping uses non-round components out of the pipe spec and the 3D library. Piping can also handle a kind of modular system having fixed lengths of ducts. This means the software is placing a unit with the maximum length which would possibly fit on a straight path, and then using the next shorter unit which fits in the remaining gap, and so on, till the whole path is filled with units. All other piping components are placed with the same automation as used in round pipes. As a result, you have a non-round pipeline like this example. Piping design with Smap3D Plant Design as a solid edge partner product is time efficient and increases the quality of the process, of the design, of the resulting documents, and therefore the quality of the entire product. Find more videos on our webpage at www.smap3d-plant-design.com. Contact us. We are happy to support you in your improvement process.